By the end of this lesson, you should be able to define elasticity, define Hooke's law, solve problems involving elasticity. Forces can move an object. They cause motion. Forces can accelerate or decelerate an object. They cause acceleration.
Forces can change the shape of an object. They cause deformation.
Of an object. They cause deformation. Some objects, like chalk, do not change shape easily. These objects break rather than stretch. They are brittle. Can you name other objects or materials that are brittle? Other objects like plasticine are not resilient. They change shape permanently when forces are applied to them. They are plastic. Name other objects or materials that are plastic. Objects like a ruler are resilient and do not break easily. They tend to return to their original shape when the forces acting on them are removed. They are elastic. Can you think of any other object or material that is elastic? When forces act on a resilient or elastic object, like a spring, the spring changes shape temporarily. Springs are coiled lengths of certain types of metal that can be stretched or compressed by applying a force to them. This makes the spring a very useful device in many different situations. Can you name some situations in which springs are useful? Here are some examples of how springs are used. Springs are used to absorb bumps in the road as suspension springs in cars, motorcycles, and bicycles. Some beds and furniture have springs in them to make sleeping and sitting more comfortable. Springs are also used in measuring devices like spring balances and bathroom scales. Springs are very useful, but to choose the right spring for a particular application, we have to first understand the elastic properties of springs. A simple observation will tell us that springs can change length when a force acts on them, and return to their original length when the force is removed. If springs are stretched beyond a certain point, they do not spring back to their original length. This point is called the elastic limit. Consider a simple experiment where a cart is attached to a spring. Initially, the spring is unstretched and at its natural length. It therefore exerts zero force on the cart. As the spring is stretched to the left, it exerts a force to the right of the cart. What do you think will happen to the force on the cart when the extension is doubled? When the extension is doubled, the force exerted by the spring is also doubled. What do you think will happen to the force on the cart when the extension is 3 times bigger? When the extension is tripled, the force exerted by the spring is also tripled. Let's draw a force extension graph for the spring. We find that the graph is linear and passes through the origin. This indicates a direct relationship between force and extension for a spring. In other words, as extension gets bigger, force also gets proportionally bigger. The relationship is known as Hooke's law. The spring constant K is determined by the gradient of the graph. Can you determine the spring constant from the graph? This spring has a stiffness of 100 Newton per meter. This means that it needs a 100 Newton force to extend it by 1 meter. The picture shows a force extension graph for the second spring. Compare the gradient of the graph for spring 1 and spring 2. What can you say about the gradient? The gradient of the graph for spring 2 is less steep than that of spring 1. Is spring 2 more or less stiff than the spring 1? Spring 2 is less stiff compared to spring 1. We can say that the steeper the gradient of the force extension graph, the stiffer the spring. Determine the spring constant of the spring 2. The second spring's graph is less steep. It is less stiff than the first spring. Its spring constant is 50 Newton per meter. It requires a 50 Newton force to extend it by 1 meter.
In this activity, you will carry out an experiment to determine the relationship between force and extension for a spring, otherwise known as Hooke's law. Click on the Add Load button so the load is added onto the spring one by one. Calculate the extension on the spring. To check the extension of the spring, click on the table. Observe how extension increases with load. What can you say about it? Let's plot a force extension graph for the spring. From the graph, we can see that force is directly proportional to extension. This is also known as Hooke's law. Can you determine the spring constant K? Complete the crossword puzzle. Mouse over to see the clues.